Hello, this is Will Watkins,
And Matthew Book.
and today we are presenting our project, which is over the heat treatment of steel. And the main objective of this project, which is pretty much like a lab, we took and cut three pieces of 1030 steel and performed heat treatments and cooling processes on them, which like a continuing cooling process. And we used a Vickers hardness tester to test the hardness of the steel after we were done. The materials and apparatus used. So we used 1030 cold roll steel, which was just scrap laying around the house that I had. And it was 3 inches wide, quarter-inch thick, and inch and 3/4 long. And then we used 15W40 burnt motor oil, which come from my truck. And then we used my portable propane forge that I use around the house for making knives and other type of tools. And lastly, we used the Vickers hardness tester, which is at school, the first floor in one of the labs.
For this project, we used Will's Forge, which you can see in the picture. We first cut off four different pieces of the same metal. One is the control metal, one for quenching in the oil, as you can see being done in the picture, one for cooling down at room temperature, and the last one for cooling in the forge with the forge turned off. We put each piece in the forge to heat up to 800 degrees Fahrenheit, then started the cooling process. The Vickers hardness tester uses a diamond-shaped head to indent the metal at a programmed force. After this indentation is done, the camera moves to the indentation and the computer measures the area, plugs in the area into the Vickers hardness formula, which you can see above is the HV formula, to give you the hardness. We measure the hardness in 3 spots on the metal and average them together to get the overall hardness. You can see in the pictures above the Vickers hardness tester and a sample of our metal and the diamond stamped indentation. Here's the results. You can see the average of all three cooling processes and the no heat treatment, the controlled metal, and you can also see the diamond Vickers hardness tester with the top picture being a harder metal which has a small diamond shaped, and the bottom picture being a softer metal which has a bigger diamond shape.
So in this experiment, we heated our steel to around 800 degrees Fahrenheit, which is around 420 degrees Celsius. So at 420 degrees Celsius, the the metal should be at its recrystallization point. So then we used a continuous cooling uh, diagram to compare the three heat treated subjects. So first we did the quench, which was less than a 10-second cooling process. So it goes, straight down to martensite. It's 100% martensite, or it should be 100% martensite. So the martensite microstructure is very hard, or has a very hard type property. And secondly, we did the ambient or room temperature test or cooling process, and it took 720 seconds to cool. So you can see on the continuous cooling diagram, 720 seconds should be right here in this area. So the second subject is martensite and perlite microstructure, mostly perlite and just a little bit of martensite. So it should be a very hard or a relatively hard material as well, just not as hard as the 100% martensite. And lastly, the end of the forge cooling. So we turned off the forge and just let the metal cool inside the forge until it was um, able to touch. And it took 7,200 seconds. So look back to the continuous cooling diagram over here, and that's in this region right here. So it's 100% perlite, or should be 100% perlite. So it should be the least hard of the three heat treated metals.
If we look at each metal individually, the one left at ambient temperature to cool down produced a harder material with a average hardness at 353 HV, which is the Victor hardness scale. Uh, the second hardest material was the in the forge cooling with an average hardness of 224.667 HV. And the softest of the three methods was quenching in the oil with an average of 152.667 HV. And we assume because the like Will said, the quenching should be the hardest. We assume that our error with this would be that we preheated the oil to above room temperature, which is normally done with normal knife making and tool making.
And our summary. So obviously heat treatment is a very good way to improve the hardness of a metal or of a steel. Even though the quenching didn't turn out like we thought it would, the other two cooling processes or heat treatment processes showed that uh, heat treatment hardens steel. And the hardness depends upon the cooling process. And the cooling process, like we saw earlier, gives you a certain type microstructure, and that just gives you certain properties, and you can pick and choose what you desire. And then last, the Vickers hardness tester provided real world data so that we could compare each of the test subjects and see how the heat treatment and cooling process affected them. And lastly, our references. Thank y'all and have a good day.